Hello friends, Mr. Burrell here. We're getting just started into Unit 11. Unit 11 is all about quadratic graphs. So far this trimester we've talked about different types of functions, their parent functions, what their parent graphs look like. We started talking about quadratic functions and what a parent quadratic function looks like. Now we've talked about factoring quadratics in Unit 9. We talked about solving quadratic functions in Unit 10. Now in Unit 11, we're going to talk about graphing quadratic functions and kind of the comparison and the relationship between quadratic graphs and all the other things associated with quadratic functions that we have discussed. So, that's what this whole unit is about, quadratic graphs. We're going to just start by introducing quadratic graphs and talk about some different properties of quadratic graphs, some different ways to write functions for quadratic graphs, etc., etc. So, for this lesson today, by the end of this video, this is what I hope you're able to do. We're going to talk about standard form of a quadratic function that you should already be familiar with. We're going to identify vertex form of a quadratic function. We're going to learn to identify what the vertex and axis of symmetry of a quadratic graph is. We'll talk about those. You'll be able to identify whether the vertex of a quadratic graph is a minimum or a maximum. Those are terms that hopefully you're familiar with. We're going to identify x-intercepts and y-intercepts. We're going to relate the x-intercepts to the solutions or the roots or the zeros of a quadratic graph. And then we're going to talk about concavity. That's a word that you haven't heard of before, probably in relation to quadratic graphs. But we're going to talk about concavity or direction of opening of quadratic graphs. So basically, we're going to look at these quadratic functions that look like this, and we're going to talk about everything possibly that we can associate with those types of graphs. Okay, so to start, some general definitions that we're going to be using in this unit, some things that we're going to be going on to discuss. First of all, you might have heard me reference this word right here before. Parabola is a name that we use for the shape of a quadratic function. So this U-shape, either that U-shape or an upside down U-shape, we call that a parabola. So this right here, this quadratic function, we often call a parabola. The vertex of this parabola is the point where the function changes from increasing to decreasing or from decreasing to increasing. So here you notice, remember when we were talking about properties of graphs, we talked about how if I'm going from left to right, when the roller coaster is going down, the function is decreasing. When it goes up, the function is increasing. So this point where it changes from increasing to decreasing, decreasing to increasing, or if it was upside down, this point right here, that's the vertex of the function or of the parabola. Because of the nature of this, the vertex will either be a maximum or a minimum. So if it's a valley, so if it's down here, that's a minimum. If it was up here, that would be a maximum because it would be a mountain. So a vertex is the point where it changes from increasing to decreasing or decreasing to increasing. A maximum would be at the top, a minimum would be at the bottom. Concavity. So when I say this word concavity or concave, if a graph has a maximum, it is therefore pointing downwards, so you can think of this as a maximum and these arrows are pointing downwards. We say the graph is concave down. If a graph has a minimum and is therefore pointing upwards, like this graph has a minimum and is pointing upwards, we say that the graph is concave up. That's just a way of expressing that the graph is pointing upwards, it's concave up, or that the graph is pointing downwards, it's concave down. So that's what those different definitions mean. So if you have my guided notes, I'd recommend referencing these terms. They're in your guided notes. If you don't have the guided notes, first of all, I'd recommend that you print them off and use them. But if not, you can write these down on a piece of paper or wherever you need to remember them. Some other definitions. Axis of symmetry. This is something that we haven't really talked about before. The axis of symmetry is the line through the graph over which you could perfectly fold the parabola in half. It is the vertical line through the vertex. So you see this orange dotted line right here? That's the axis of symmetry, because if I were to fold the parabola over that line, right in half on the graph, it would land exactly back over itself. Or another way that you can think of it is the axis of symmetry is the vertical line through the vertex. So the equation of this line is where x is equal to the x-coordinate of the vertex. So for example, on this graph right here, the vertex is 1, negative 4, because it's 1 in the x direction, negative 4 in the y direction. So therefore, the axis of symmetry is this line right here at x equals 1. So the vertex is 1, negative 4, and the axis of symmetry is x equals 1. So again, axis of symmetry is that line, vertical line through the vertex that would cause the parabola to fold exactly in half. X-intercepts, I better move this down a little bit. X-intercepts are the points where the graph cross the x-axis. So right here and right here. On this graph, they're at negative 1 and positive 3. So the x-intercepts are x equals negative 1 and x equals 3. These points, these x-intercepts, are also called the solutions, or the zeros, or the roots. There's a bunch of different words that sometimes they are called. But those are the solutions of this quadratic graph. You know, in the last unit, we talked about solving quadratic functions. Those numbers that you found when you were finding the solutions, or the zeros when you were talking about factoring, or the zero product property, or the quadratic formula. When we're finding those solutions, we're talking about these points where the graph crosses the x-axis, kind of making a connection between those two worlds here. And then the last thing, y-intercepts are the points where the graph crosses the y-axis. So right here where the graph touches the y-axis, that's going to be a y-intercept. So those are some general definitions, some general things that we're going to be using and discussing in this unit. So, I'm going to bring you back to something that we talked about in Unit 10. Every quadratic equation has two solutions. Do you remember that? Every quadratic has two solutions. There are three options. One real solution repeated twice, two real solutions, or two complex solutions. Those are the possible solutions that we had in Unit 10 when it came to quadratic functions. Now I want to make a connection between those quadratic functions that we solved and these graphs that we're going to start talking about. So the graph of a quadratic function that has one real solution repeated twice is going to look something like this. Whether it's right side up or upside down, it's going to touch the x-axis one time. The vertex will be on the x-axis. It has one solution. A quadratic function that has two real solutions is going to cross the x-axis in two places, like this. Maybe like this if it was upside down. A quadratic function that has two real solutions, the graph will look something like this. It will cross the x-axis two times. A quadratic function that has two complex solutions will not touch the x-axis. Notice there's nothing touching the x-axis here. If I wanted to write one upside down here. A quadratic function that does not touch the x-axis will have two complex solutions. You can also start in your brain start to think about how those graphs and how those solutions will relate to the sign of the discriminant in the quadratic formula. Hopefully you can make some of those connections here. But these are the big ones that I want you to remember as far as what the solution of a quadratic function looks like compared to what the graph of that quadratic function will look like. Okay. So, we're going to start here, now that we've talked about these definitions, we're going to start talking about quadratics in two different forms. So standard form, ax squared plus bx plus c, which we've already discussed a lot in Unit 9 and Unit 10. And we're also going to start talking about vertex form. This form might be more familiar to you from Unit 8 when we were talking about parent functions and we were talking about transformations. We're going to call vertex form, the vertex form of a quadratic function. So if I have ax squared plus bx plus c, that's standard form. If I have a and then this x minus h, x and a some number in parentheses squared plus some number on the outside, that's going to be vertex form. So here it says identify which form the following quadratics are in. Well, this one right here, I can see these parentheses and the squared. That's going to be vertex form. This one right here, ax squared plus bx plus c, that's going to be standard form. This one right here is also going to be standard form. And this one right here is going to be vertex form. So that's part of this lesson. I want you to be able to identify what form a quadratic function is written in. This is standard form. This is vertex form. Okay. So in vertex form, HK is the vertex of the quadratic. So here was my vertex form, x minus h squared plus k, y equals a times x minus h squared plus k. So the vertex is going to be the opposite of this number in here, so h, and then the same as this number out here, so k. So this was number 1 and number 4 from the previous slide. So this question says, list the vertex of numbers 1 and 4. So number 4, the vertex would be negative 3, positive 1, because it's the opposite of this number and the same as this number. The vertex of number 4 here would be the opposite of negative 2, so positive 2, and then the same as this number, negative 8. So the vertexes of those functions, those graphs, those quadratic graphs would be at negative 3, positive 1, and 2, negative 8. So, remember, I want you to make a comparison here, make a relationship. Remember when we were talking about transformations of parent functions, I talked about inside the parentheses causes the graph to move left to right, and outside the parentheses here causes the graph to move up and down. And then this number out front would affect how fat or skinny it is, and then if it was negative, it would flip it upside down. So we talked about that with a bunch of different kinds of functions. So it continues to apply with this quadratic function in this form. When I have a quadratic function in vertex form, really I can just think about the vertex of that parabola being transformed according to these rules that we've already talked about. So again, if a is negative, the parabola flips upside down. H moves the function left to right, the opposite of the sign that's given. K, or this number on the outside of the parentheses, moves the parabola up and down, the same sign as the sign that's given. So this should look, hopefully, pretty familiar to you, and hopefully it starts to come back as we work on some of these problems. Okay, so this is an example of a problem you might see on the homework or on a test or something like that. So this says, for each graph or equation, identify the following characteristics. So it's going to ask us to find a bunch of the things, a bunch of the characteristics associated with this graph. So, vertex. Where is the vertex of this parabola? Where it's the place where it changes from increasing to decreasing. So this point right here, what is that point? Well, it's 2 in the x direction and 1 in the y direction, so the vertex is 2, 1. Next it asks, is that a maximum or a minimum? Or is it a mountain or a valley? Mountain or valley? So since this is a maximum, this is a mountain, since this is a mountain, this is going to be a maximum. Right there. Concavity, which way is it pointing? It's pointing down. So this is concave down. So that's what those terms mean. Since this is facing downwards, it's concave down. Where is the axis of symmetry? Well, this line through the vertex, right there is my axis of symmetry. That's at x equals 2. It crosses through 2 all the way down. So my axis of symmetry, or the line over which I could fold this parabola in half, is x equals 2. Next, it asks me for the zeros, or the x-intercepts, or the solutions, or the roots, whatever you want to call them. These points right here, where I cross the x-axis, where y is equal to 0, notice that this is where y is equal to 0. Those are my x-intercepts. So at x equals 1 and x equals 3, those are my zeros, or my x-intercepts. My y-intercept is right down over here where I cross the y-axis, or where x is equal to 0. My y-intercept is y equals negative 3. So those are some of the characteristics of this quadratic graph. And there will be a problem like this on your homework where there's a graph like this and they want you to identify these different characteristics. Okay. What if I don't give you a graph, I just give you a function? If I give you a function, these are the types of characteristics that I'm going to ask you for. So before I find this, I'm going to draw a rough sketch of what this graph is going to look like. Okay. So my traditional original quadratic parent function is going to look something like this. right, crosses through 0, 0. It's a parabola. It's facing upwards. So how is this graph changed? Or what are the transformations here? Well, this -5 means it's flipped upside down and it's squished a little bit. There's a vertical stretch. So I know it's going to be flipped upside down. This means I'm moving to the left 3 units and down 6 units. This number in here moves left to right, the opposite of the sign that's given. This number out here moves up and down, the same as the sign that's given. So this is going to move to the left 1, 2, 3, and down 1, 2, 3, 4, 5, 6. So that right there is a sketch of my graph. Okay, I have a rough sketch. This isn't a perfect sketch, but now I have probably enough that I can identify some of these characteristics. Well, where is the vertex? Well, the vertex is left 3 and down 6, so it's -3, -6. The opposite of this number, the same as this number. -3, -6. That's my vertex. Is that vertex a maximum or a minimum? Well, it's pointing downwards. So this up here is going to be a little mountain, so that's a maximum. That's as high as that graph is going to get. That's a maximum. Concavity, which way is it pointing? Well, it's pointing down. Whoops. So that's going to be concave down. And lastly, what's the axis of symmetry? Well, the axis of symmetry is the same as the x-coordinate of the vertex. Right here, this axis of symmetry is going to be right through the x-coordinate of the vertex. So the axis of symmetry is x equals -3. Okay, those are all the properties that I wanted you to identify on this graph. Let's do another one. So I have y equals x minus 4 squared plus 3. Well, the traditional quadratic graph is going to look something like that. That's the parent function. So there's no number out here, so it's not flipped upside down. It's not squished at all or anything. So this right here, the -4 and the +3, this is going to transform my function right 4 and up 3. So I'm going to go 1, 2, 3, 4, and then up 1, 2, 3. So my new graph is going to be something like this. Again, this is a rough sketch, but that's going to be enough to identify the characteristics here that I want you to identify. The vertex of this parabola, or this quadratic function, is what? Well, I went to the right 4 and up 3, so my vertex is going to be at 4, 3. 4 in the x direction, 3 in the y direction. Is that vertex a maximum or a minimum? Well, it's a little valley. It's at the bottom. That vertex is at the bottom, so this is going to be a minimum. Which way is the graph pointing? It's pointing up. It's facing upwards. So this is the concavity is going to be concave up. It's pointing up here. The axis of symmetry, again, is the line that goes directly, the vertical line that goes directly through the vertex, through the x-coordinate of the vertex. So my axis of symmetry is x equals 4. Okay. So that was our introduction to quadratic graphs. Some of the basic characteristics of quadratic graphs, how we can identify changes that have been made to a quadratic graph, identifying standard form, vertex form. Hopefully you are now more equipped to and understand more all of these objectives here. If there's any you're unsure of, please go back in the video and identify those parts that you're concerned about. But that's the introduction. We're going to spend the rest of this unit continuing to talk about quadratic graphs and different ways that we can identify these specific characteristics and how we use quadratic graphs in association with what we've already talked about with solving quadratics. And I hope that you enjoyed that as much as I did.